So you're not sure you can explain the motion of an object in free fall. For this quick review, we will talk about a definition. We will talk about what constant acceleration is. We will look at the equations that we use, and we'll take a look at some examples. Defined. A free-falling object is an object that is falling under the sole influence of gravity. Any object that is being acted upon only by the force of gravity is said to be in a state of free fall. So free fall, the object is only being acted upon by gravity. Now there are two important things that I want you to recognize. True free-falling objects do not encounter air resistance, because if they do encounter air resistance, then they are not only being acted on by gravity. All free-falling objects on Earth accelerate downwards at a rate of 9.8 meters per second squared. Now let's talk about what a constant acceleration is and what it is for objects in free fall. We've talked just momentarily about the fact that a free-falling object is an object that is falling under the sole influence of gravity. A free-falling object has an acceleration. That acceleration here on Earth is 9.8 meters per second squared, and it is always, repeat after me, always acting in the downward direction. Now, we have given this specific acceleration a unique symbol. That symbol is the letter G. So gravity here on Earth is equal to 9.8 meters per second squared downward. Now, there are slight variations in this value that are dependent primarily upon altitude, and we will look at that in more detail when we do our unit on gravity. Now, is gravity a universal constant? Well, everything that has mass does experience gravity, but this value of 9.8 meters per second squared is actually very unique to our Earth within our solar system. Other planets will have different masses and therefore will have different gravitational accelerations. What equations do we use when we are figuring out how things are moving, the motion of objects in free fall? Well, a couple of questions you need to ask yourself. First of all, how fast is your object falling? If you're trying to figure out how fast an object is falling when it is in free fall, then you need to remember that it is experiencing a constant acceleration. And what is that constant acceleration? That's right, it's our G, 9.8 meters per second squared. So when you are trying to figure out how fast an object is falling, we will use our equation. Velocity is equal to the initial velocity plus AT, A being acceleration, and so for an object in free fall, it will be the gravitational acceleration. Now, if you want to know how far, we will go ahead and use our distance equation. Remembering that our object is experiencing constant acceleration, that constant acceleration being the force of being gravitational, being our 9.8 meters per second squared. So, the equations that we will use to figure out how fast and how far. Now, what if I need to figure out how long an object has been falling for? Then I need to figure out what time is. In order to figure out time, I'm going to use d is equal to 1/2 at squared in order to calculate that time feature. To do this, I need to solve for t. To solve for t, I'm going to shift the values over to the other side. To shift the 1/2 over, I'm going to multiply both sides by 2. These multiplied together will equal 1, and 1 times anything is the anything. Then I will divide both sides by our acceleration. Once again, any value divided by itself is 1. Then in order to get the t by itself, I will take the square root value. So my equation to figure out time is t is equal to the square root of 2 multiplied by the distance divided by the acceleration, which in our particular case is gravity. Let's take a look at some examples. For our first example, Luke drops a pile of roof shingles from the top of a roof located 8.52 meters above the ground. Determine the time required for the shingles to reach the ground. All right, what is it that we know? We know that the distance that the shingles are dropping is equal to negative 8.52 meters. Now, why did I choose a negative value here? Because from Luke, which I am choosing as my frame of reference, this would be our 0 mark, and where they landed would be our value. I've decided that if it went above Luke, it would be positive. If it's going below Luke, it will be negative. So the value will be a negative 8.52 meters. We also know that these shingles started from rest, so there is no initial velocity. And as a definition, we know that the acceleration involved here is gravity. And gravity has a value, always going down, of 9.8 meters per second squared. So what have we been asked to figure out? We've been asked to find the time. Now as far as our equations go, we have quite a bit of information that's been given to us. But we know a distance, we know an acceleration, and we need to figure out a time. So we're going to go ahead and take a look at our distance equation. As we look at it, there are some things we can eliminate. We don't have an initial velocity, so we don't need to deal with that section. Do we know a distance? We do. Do we know an acceleration? We do. So the only thing we need to do is solve for t. Now, as you just saw, we can solve for t using simple algebra, and we come up with t is equal to 2d divided by the acceleration of gravity and the square root of the process. So what will our calculation look like? Square root of 2 multiplied by negative 8.52 meters divided by negative 9.8 meters per second squared. All we have to do is solve it now. And we come up with the answer that time is equal to 1.32 seconds. If you need more review, please go to your portfolio and check out your review assignment. Have a good day.